Very good morning, students. Today's topic, the coordination compound. Now the synopsis. The first I can discuss what the introduction. What is introduction? The first is the introduction. What is the coordination compounds? The coordination compounds are also called what? Inorganic salt. And even though these coordination compounds are also called what? Complex salt. Actually, these compounds are widely present in what? Minerals, plants and what? Animals. The common examples are the hemoglobin. The hemoglobin is a complex of what? Iron. And then the next is the chlorophyll. Also is an example of what? The magnesium complex. And vitamin B12 is a coordination compound of what? Cobalt. So here, what is the coordination compound? The coordination compounds, they are nothing but a inorganic salt, and even though they are also called what? A complex salt. Okay. The next is what here? The next slide is what? A double salt. What is this double salt? In this double salt, yes. What is this double salt? Okay, see here. In this double salt I can discuss here. This double salt, what is the double salt? The double salts are the molecules of the compounds. It exists only in water, solid state. Okay, they exist only in the solid state. The example for these double salts are what? Carnallite. What is the formula? It is a KCl MgCl2H2O. And next is what here? Next is the Morse salt. The formula of this Morse salt is what? FeSO4, NH4 times SO4. FeSO4 is one simple salt, and NH4 2SO4 is one simple salt. These two simple salt, it becomes what? It becomes what? A double salt. And one more example is what? Potassium. So the potassium, it consists of one simple salt K2SO4. The second simple salt Al2SO4 thrice. These two simple salt becomes what? A double salt. Okay. The next is what here? This is the double salt. The next, what is the coordination compound? These coordination compounds are also called what? Complexes. The coordination compounds are those the molecular compounds which retain their identities both in solid state as well as what in the dissolved state or any other solvent. So this is called what? Coordination compound. So the main point you have to remember. So what are the double salts? The double salts are made up of what? Two simple salts. Yes. The double salts are made up of what? Two simple salt. Okay. The two simple salt becomes what? Double salt. The example is what? Carnallite. Here the two simple salt, one is KCl is there, one is KCl, another one is what? MgCl2. And in the Morse salt, it is a double salt. One is simple salt is FeSO4, second is NH4 times SO4. These two simple salt becomes what? Double salt. Okay. Next slide. Okay. So in the next slide, so I can discuss. So what is meant by coordination compound is over. Yes. The next is the example for this coordination compound here. Yes, my dear students, the example for this coordination compound is K4FeCN6 is an example of what? A complex salt. Okay. So here and actually in this K4FeCN6, this yellow color, this is the square bracket. This square, only the square bracket, it indicates what? It indicates what? Complex ion. This K4FeCN6, this square bracket, it indicates what? Complex ion. Okay. What is this complex compound? The complex compound in which the metal atoms is bound to a number of what? Anion or the neutral molecule. Such compounds are called what? Coordination compound. It means the coordination compound, it contains what? This is the iron is the central metal atom. This is the group of ions are called ligands. Okay. So this is about what? Coordination compound. Yes, my dear students. The next is here. Coordination entity. Okay, see here. One by one I can discuss. The first is what? Coordination entity. What is this coordination entity? The first is what here? Now, this is the coordination. What is this coordination entity? Coordination entity constitutes central metal atom are bonded to what? Bonded to fixed number of ions and molecule. So here, this is called what? This completer I can show with help of this green color. This is the complete. This is called what? This is called what? Coordination entity. In this coordination entity, this is CO is called what? This is CO is called what? Central atom. This is CO is called what? Central atom. This CO is called what? Central atom. Okay. This contains what? Central atom. And this NH3 is called what? This NH3 is called what? This NH3 is called what? the group of ions. This group of ions are called what? Ligands. Yes, my dear students. What is the coordination entity? The coordination entity, it contains central atom. Which is the central atom? Cobalt. Cobalt is the central atom. And ion is bonded to a fixed number of water. Ions are molecules. So this NH3. NH3 is nothing but the fixed number of molecules. This fixed number of molecules is called what? Ligand. And the next is what? What is the central atom? In a coordination entity, this is the coordination entity. Okay, in this coordination entity, atom or ion to which a fixed number of ions or groups are bonded to a different geometrical arrangement, it is called what? Central atom. In this example, cobalt is the central atom. Cobalt is the central atom, my dear students. Yes, the cobalt is the central atom. Cobalt is nothing but a central atom. Okay, yes. And one more is what here? NH3 is there. So this NH3 is nothing but a group of molecules or ion. This group of molecules or ion, these are called what? Ligand. These are called what? Ligand. So this is what is the coordination entity. So this is the coordinate. This is the square bracket and it contains what? Central atom CO, and next it is the group of ions. This is what? NH3, and this is what? NH3, and it is what? Thrice. So this is complete. It is called what? Coordination entity. In this coordination entity, it contains square bracket. In this square bracket, it contains central atom cobalt, and ammonia is what? Ligand. Okay, my dear students. And the next slide is okay. So the next slide is coordination entity. B is what? Central. Next slide. Okay, here. This next slide. So I can discuss here. Yes, my dear students. Okay, what is the central metal atom? Yes, my dear students. Yes. So in the central metal atom, which is the central metal atom? In this coordination entity, nickel is the central metal atom. This is the nickel. Nickel is the central atom. And in this complex, which is the central atom? Cobalt is the central atom. Similarly, so in case of which is the central metal atom? The central metal atom is what? Iron. So in case of this, these are the coordination entity. This is the one coordination entity. Nickel is the central atom. And next coordination entity. This is the second coordination entity. The central atom is cobalt, and this is the third coordination entity. So the central atom is what? Iron. So this is what everybody. So it is. And even though these central atoms or ions are called what? Lewis acid. Why it is called Lewis acid? Because it takes what? Electron. It takes what? Electron. Okay. Takes what? Electron. So it takes electron. So that's why these central atoms or ions are referred to as Lewis acid, because it takes E minus. E minus means what? It takes what? Electron. It takes what? Electron. So that's why it takes electron. So these are called what? Lewis acids. And the next very important concept is so ligands. What are the ligands? The ligands are nothing but ions, or the molecule is bonded to what? Central atom or to the central ion through in a coordination entity, or the ligands can donate one or more pair of electron to central atom, is forming a coordinate bond. Yes, my dear student, what are the ligands? In this example, water is ligand, and even though Cl is what? Ligand, and next here NH3 is what? Ligand. NH3 is also ligand, and next you come to this here the cyanide is what? Ligand. Okay, in this coordination entity, nickel is central atom, cobalt is central atom, and iron is what? Central atom. So cobalt is the center. But what are the ligands? The ligands or the ions or molecules bound to what? Central atom. So in this first coordination entity, chloride is what? Chloride is ligand. Water is ligand. NH3 is ligand. Cl is ligand, and Cn is what? Ligand. So these are nothing but ligands. Ligands examples are water is ligand, Cl is ligand, ammonia is ligand, and cyanide is ligand, my dear students. And next is what here? Now the classification of ligands. So the ligand which can coordinate with central matter ion through one donor atom. If any ligand having one donor atom, or it gives only one pair of electron, so these ligands are called what? Monodentate ligand. Example for this monodentate ligand is what? Water is monodentate ligand, Cl is monodentate ligand, and next is what? Ammonia is what? Monodentate ligand, and next Br minus is what? All these are the examples of what? Monodentate ligands. Next is what here? Next monodentate is what? Next classification is Bidentate ligand. Okay, my dear students. Bidentate ligand. Yes. What is this bidentate ligand? Example, bidentate ligand. The bidentate ligand, it has how many donor atoms? 2 donor atoms. So it is having 2 donor atoms. So it is called what? Bidentate ligand. Example for the bidentate ligand is ethane 1,2 diamine. Because so this is an example of what is a bidentate ligand, because it has a 2 donor atom. It has how many donor atom? Yes, I can show with that for this color. NH2 is 1 donor atom and NH2 is what? 1 donor atom. Total 2 donor atoms are there. Total how many donor? 2. So it is called what? Bidentate ligand. So the next example is dimethyl glyoxan. Here is already N is 1 donor atom. Here N is 1. Total 2 donor. How many donors are there? 2 donor atom. So 2 atoms are there. So it is called what? Bidentate ligand. Next comes to what? Oxalate. Oxalate I can write like this. This is the oxalate. CO minus. CO minus. Yes. How many donors are? Oxygen is 1 donor. Oxygen. Total how many are donors are there? 2 donors are there. So oxalate is what? Bidentate ligand. Similarly here, nitrogen is 1 donor. Oxygen is 1 donor. Total donor atoms are 2. If 2 donor atoms, so it is called what? Bidentate ligand. So here ethane 1,2 diamine. Nitrogen is 1 donor. Nitrogen 1 donor. 1 donor. 1 plus 1 2. Here is nitrogen donor. Nitrogen donor. In case of oxalate, I have written here 1 oxygen donor, 2nd oxygen donor. And in case of this example, so here is also what? Glycinate. Here is nitrogen is 1 donor and oxygen is 1 donor. Total 2 donors are there. 2 donors means what? Bidentate ligand. And next is the polydentate ligand, which have more than 2 donor atoms. So it is called what? Polydentate ligand, my dear students. And the next is what here? In this polydentate ligand, so 3 types are there: tridentate, tetradentate, next pentadentate, and what? Hexadentate. Yes, my dear students. Tridentate ligand. Yes, tridentate ligand. The tridentate ligand, it has how many donor atoms? 3 donor atoms. Okay, 3 donor atoms are there. Yes, I can show. I can show here with help of this color. Yes, here. Example is diethylene triamine. Diethylene triamine. So we can write here. We can write it is shortly. We can write what? Di-en. In some di-en, it indicates what? Di-en, it indicates nothing but this is the. We can shortly. We can write shortly. We can write di-en. Di-en is nothing but diethylene triamine. How many donors are there? Yes, I can count the donor atoms. Here is nitrogen is 1 donor. Here nitrogen is 1 donor. Here nitrogen is 1 donor. Total how many donors are there? Total 3 donors are there. So 3 donors are there. So these three donors are called what? Tridentate ligand. All these 3 donors are 3 donor nitrogens. So that's why. So it is called what? Tridentate ligand. Shortly we can write it is called what? Di-en. Di-en is nothing but diethylene triamine. And the next is what here? The next is what here? The next I can discuss, my dear students. The next concept is tetradentate ligand. The tetradentate ligand, it has how many donor atom? It has 4 donor atom. Yes. Now it is called what? Triethylene tetramine. Triethylene. How many ethylenes are there? 1 ethylene, 2 ethylene, 3 ethylene. Triethylene tetramine. How many amines are there? How many donors are there? Yes, see how to count here. How many donors? Donors number 1, donors number 1, donors number 2, donors number 3, donors number 4. Total 4 donor. Total how many donor? 4 donor. All these 4 donors are nitrogen. So it is called what? Tetradentate ligand. Tetradentate ligand has 4 donor. Nitrogen 1 donor, nitrogen 2nd donor, nitrogen 3rd donor, nitrogen 4 donor nitrogen. So it is an example of what? Tetradentate ligand. Shortly we can call it as. Shortly we can write it as tri-en. It is called tri. Why it is tri-en? 1 en, 2 en, 3 en. It is called what? Tri-en. How many nitrogens are there? 1, 2, 3, 4. It is called what? Tetramine. And the next is what here? Hexadentate ligand. So the next is what here? Hexadentate ligand. In this hexadentate ligand, yes. In this hexadentate ligand, yes, my dear students, yes. Hexadentate, very important question. Hexadentate ligand. Hexadentate ligand, it contains how many donor atoms? 6 donor atoms are there. So it is called what? Ethylene diamine tetraester. Shortly we can call it as EDTA. How many donor you have to count here? Yes, with help of yes, I can draw. Nitrogen is one donor, donor number 1. Nitrogen is 2, it is a donor number 2. And next is I can go for yes, this is one oxygen donor, 1. Here is oxygen donor, 2. Here oxygen donor, 3. Here oxygen donor, 4. It means how many nitrogen donors? 2 nitrogen donor. 2 nitrogen donor. Yes, my dear student. 4 oxygen donor. 4 oxygen donor. So 4 plus 2. 4 plus 2, 6. 6 means what? 6 means what? A hexadecade. 6 means what? A hexadecade. 6 donor means hexadecade. In this 6, 2 nitrogen donor, 4 oxygen donor. So that's why the CET examination you have to concentrate. In a EDTA, it is a hexadecade ligand, 2 nitrogen donors and 4 oxygen donor, total 6 donor. It is called what? EDTA. So this green color, it indicates what? The 4 oxygen donors, and this pink color, or it is indicates what? These are the 2 nitrogen donors, my dear students. The next part is, okay, ligands are over. The next very important is ambidentate ligand. Yes, my dear. Okay, just a minute. What is the ambidentate ligand? The ambidentate ligand which contain more than one donor site, but coordinate central metal. I am using one of the site. Very important. One of the site. Yes, my dear students. I am discussing here. Very important. Here, NO2 group can coordinate through nitrogen or oxygen. NO2 is a ambidentate ligand. So here is the in first case it is a nitrogen donor. So it is read as a nitro. So here this is a NO2 is a ambidentate ligand. Okay, my dear students, NO2 is a. If nitrogen it gives electron, it is called what? A nitro complex. It is read as nitro complex. Suppose same NO2, ONO, same it is. If oxygen is the donor, so it is read as a nitro complex. It is read as nitro complex. And even though similarly, yes, my dear students, similarly, I am discussing about here. Next is the next example is this is what? Cyanide CN group coordinate through carbon or nitrogen. Yes, here the cyanide. Cyanide is a ambidentate. Okay. Suppose if carbon gives electron to central atom, so this is read as a cyanide complex. It is read as a cyanide. Same ambidentate ligand, if nitrogen is the donor, it is read as a isocyanide. It is read as a isocyanide. So this ambidentate ligand means it has 2 donor atom, but only one can attach to what? Central metal atom, or only one can using as a site. So it is called what? Ambidentate. Example for ambidentate ligand: NO2 is ambidentate, cyanide is ambidentate, and thiocyanate is a ambidentate ligand. And one more is the chelating ligand. Chelating means what? Ring formation. Chelating means what? Ring formation. So when these ligands, for example, ether 1,2 diamine. So shortly we can say it is EN. EN is nothing but a bidentate ligand. It is a bidentate ligand. Okay, it is a bidentate. So ether 1,2, shortly we can say EN. It is called bidentate ligand. So the bidentate ligand. So when it is bonded towards central atom, so it forms a ring structure. So these are called what? Chelating ligands. Okay, my dear students. The next is chelating ligands is what? The next is what? Here, coordination number. Yes, very important. What is the coordination number? Yes. So coordination number means the total number of ligands attached to central atom, or total number of coordinates formed in the metal atom and ligand. So for example, I can write one complex, my dear student. This is Cu, and it is what? NH3. CuNH3, and this is what? 4, and it is OK. So this is copper is what? Central atom. Ammonia is what? Ligand. How many ligands are attached? 4. 4 ligands are attached. It means coordination number is 4. Correct, my dear friends? And one more example. Yes, another example. Okay, this is all. The next I can go for second. Now one more example. K4. Yes, this is the K4. This is Fe. CN6. This is what? CN6. Okay, my dear students. Yes, CN6. So this is a complex. In this complex, cyanide is a ligand. How many ligands are attached? 6 ligands are attached. 6 ligands are attached. What is the coordination number? Coordination number is called what? Coordination number is what? 6. Okay, my dear students. Okay. So one more example I can discuss here. Okay, this is it over. The next example is The next example is I can take here. So I can take one more example. CO. This is the cobalt. This is the central atom, and this is En twice. En twice. Okay, En twice. Okay, my dear students. En. Okay. So then I will take this. Okay. This is what? CO, and it is what? En. This is what? Twice, and it is what? Cl. SCl. So what is the coordination number? Actually, coordination number is what? 6. The coordination number is 6 because En is a bidentate. So En is a bidentate. Cl, how many Cls are there? Cls are 2. Cls are 2. Okay, Cls are 2. How many Ens are there? Ens are 2. Ens are 2, but En is a bidentate ligand. Bidentate ligand means it has 2 donor atoms. So 2 into 2 is equals to what? 4. 4 plus 2 what? 6. Hence the here ligands are 4. 2 Cl ligands, 2 En ligands are 4. But En is a bidentate ligand. Bidentate ligand means you have to multiply with what? 2. 2 into 2, 4. 4 plus 2, 6. Hence the coordination number of cobalt is what? 6. So this is called what? This is called what? Coordination number. And the next thing is here. The next is what here? The next thing is I can discuss it. So what is the coordination sphere? It is a part of the coordination compound containing central metal atom, ligand and directly attached to what? Coordination sphere. The coordination sphere is written in a square bracket. Yes, my dear student. So in this complex, this is I am showing this. Yes, this is what here. This is K4Fe6. This is the part. This part only is called what? Coordination sphere. Coordination sphere contains central atom, ligands. So this is called what? In the complex K4FeCN6. So only FeCN6 is called what? Coordination sphere. For example, I can write one example. What is the coordination sphere? This is K4. This is K4. Next is what? Fe. This is what? Cn. This is what? Cn. And it is what? 6. This is one complex. This is one complex. But in this complex, so only the square bracket, only this square bracket is called what? Coordination sphere. Coordination sphere, it contains central atom and ligand. So and this is K4 is nothing but a ionic sphere. It is called what? Ionic sphere. It is called as ionic sphere. Okay, ionization sphere or counter ion. Even it is also called what? K4 is a counter ion and square bracket is nothing but a coordination sphere. Okay, this is one. Next is what? Okay, ionization sphere is one. The next is what? Okay, the coordination polyhedron. What is this coordination polyhedron, my dear students? So what is this coordination polyhedron? Okay, in this coordination polyhedron, the spatial arrangement of spatial arrangement of ligands atoms which directly attach to the central metal atom. Yes, my dear students. So coordination polyhedrons are octahedral, square, planar and tetrahedral. So in this complexes, this is the complex I am discussing. CO. Okay, this is NH36. This is what? NH36. NH36. So this 6 is means what? 6 is nothing but a octahedron. 6 is nothing but a octahedron. 6 is nothing but a octahedron. What is the coordination polyhedron? Octahedron. So one more complex is here. NiCO. NiCO4. Yes, NiCO4. So this is the NiCO4. What is the coordination number? 4. Coordination 4. It is what is the coordination polyhedron? Coordination polyhedron is tetrahedron. Coordination polyhedron is tetrahedron. So one more example is PtCl4. This is what? PtCl4. Yes, PtCl4 minus 2. So what is the coordination number? Coordination number is what? 4. But what is the coordination polyhedron? It is a square planar. It is nothing but a square planar. So it is nothing but a square. So what is the coordination? Here in this complex coordination number is 6. It is called octahedron. Here coordination number is 4. It is called what? Tetrahedron. Here the coordination number is 4 and it is called what? Square planar. Okay. So these about the coordination polyhedron. The next is what here? Complex ion. Here is the complex ion. I can discuss here. What is this complex ion? Okay. Yes, my dear students. So what is this complex ion? A complex ion may be electrically charged species which contains what? Central metal atoms surrounded by ligands. So this is what nothing but these are the complex ion. Why it is called the complex ion? So this is Ag, this is Cn2 and it is having a charge. It is having the what? Charge. Whether it is a minus or plus, but they are called as complex ion. Whether it is a negative, it is called anionic. It is called what? Complex ion. Suppose if it is a negative, it is called complex anion. If it is a positive, it is called complex cation. So what is the complex ion? The complex or means the square bracket having either positive or negative charge, it is called what? Complex ion. Next is types of complex ion. Types of complex ion, my dear students. In this types of complex ion is just for types of coordination complex. Anionic complex. Anionic complex, one which that contains complex ion which has a negative charge. Here is one complex ion. Potassium ferrocyanide is an example of anionic complex. Why it is called anionic complex? So here this is K4, this is K4 and it is what? FeCl6. FeCl6. Okay, FeCl6. Okay, FeCl. It gives what? It gives 4K plus. It gives 4K plus of what? FeCl6. It gives FeCl6. This is what? Minus 4. FeCl6 minus 4. It means what here? This is minus 4. So it means, so in K4 FeCl6, 4K plus is called what? Counter ion. FeCl6 minus 4 is called what? Coordination pair. Here the coordination pair is what? Negative. Here the coordination pair is what? Negative. So that's why it is called what? Anionic complex. So in K4 FeCl6 complex, anion is what? Anion is what? Negative charge is what? FeCl6 minus 4. Here square bracket is what? Negative. If square bracket is negative, hence this complex is called what? Anionic complex. Okay. And the next is what here? The next it is anionic complex is what? The next I am discussing cationic complex. Okay. What is this cationic complex? Yes, my dear students. Here is the cationic complex. So cationic complex, cationic one which contains what? Complex ion which has net positive charge. Okay, my dear students. Okay, I can write here one example I am writing. Okay. Okay. So here I am writing. So this I can take here Cu, NH3, NH3, 4 and SO4. SO4 is one complex. So it dissociated gives what? It dissociated gives Cu, NH3, okay, NH3, okay, just a minute. Here I can write, direct I can write here. Okay, here the CuNH3 4 is there and it gives what? Cu, NH3, NH3, 4 and it is what? Plus 2 plus SO4 minus 2. Okay. So this CuNH3 complex, it gives square bracket having positive charge and next is what? Negative charge. The square bracket having a positive charge is called what? Cationic complex. It means in a complex CuNH3 contains the complex cation is what? The complex cation is what? CuNH3 2 plus square bracket is positive, hence it is called what? It is called what? Cationic complex. And next is what here? Next is the neutral complex. Next is the neutral complex. The neutral complex is one which does not contain charge on this coordination component. Yes, my dear students, yes. Suppose here, in this complex, no counter ion, no counter ion, no counter ion. So no counter ion means what? Only no counter ion, only square bracket, only square bracket, only square bracket, only square bracket, only square bracket means coordination sphere, only square bracket means what? Coordination sphere, only coordination sphere. So only coordination sphere, so there is no counter and only square bracket, or only square bracket means only coordination sphere. So these are called what? These are called what? Neutral complex. And the next one is here. The next is what here? The next is important thing is homoleptic is same, heteroleptic is different. The complex is bound to only one kind of what donor group, only one kind. Here is ammonia is only one kind. All the ligands are ammonia. Here all ligands are same cyanide, so it is called what? Homoleptic complex. And next is what here? The complex in which the metal is bound to more than one kind of donor. Here ammonia is different, Cl is different. Here ligands are different. It is called heteroleptic. Here the ligands are all ligands are ammonia. Here all ligands are ammonia. Here all ligands are cyanide. All ligands are same. It is called homoleptic. Here in this coordination entity the ligands are what? Different. So it is called what? Heteroleptic complex. Next is here Werner's theory of a coordination compound. Actually in the Werner's theory of coordination compound, so the two types of valencies are there. One is primary valency, another one is what? Secondary valency. And the primary valencies are ionizable and it is what? Oxidation state, and primary valencies are satisfied by negative ion. Yes, my dear student, I can discuss one example here. I can take Cu, NH3, this is 4 and it is what? It is what? SO4. What is the oxidation state of copper? Oxidation state of copper is +2. This +2 is called what? Primary valency. This +2 is called what? Primary valency. It is called primary. Here what is the coordination number of copper? The coordination number is what? 4. This coordination number is 4. It is called what? Coordination number is 4. It is called what? Secondary valency. It is called secondary valency. So the coordination compound has two types of valency. One is primary valency, another is what? Secondary valency. The primary valency is nothing but an oxidation state, and the secondary valency is non-ionizable. And even though the secondary valency is nothing but the secondary valency is equals to what? Equals to what? Coordination number. In this complex, the oxidation state of copper is +2. It is called primary valency. Coordination number is 4, so it is called secondary valency. So one more example I can discuss. My dear students. Yes. So what is the example? I can take here one more example. I can take. This is the K4. K4 is ionic sphere, and the square bracket is called what? Coordination sphere. This is Fe is the central atom, and Cl is a ligand. And total it is a complex. K4 is a IS. IS means what? Ionic sphere. And this is called what? CS. CS means what? Coordination sphere. And in this, what is the oxidation state of Fe? The oxidation state of Fe is what? +2. +2 is called what? PV. PV means primary valency. What is the coordination number of iron? Cn. Cn means coordination number. Coordination number is what? 6. 6 is called what? 6 is called what? Secondary valency. It means the coordination consists of two valencies. One is primary, another one is what? Secondary. Primary is nothing but a oxidation state, and the secondary valency is nothing but a coordination number. Yes, my dear students. The next is here. Okay. Next is the nomenclatures are there. In the nomenclature, what you have to do? The first in the nomenclature, first you have to write down what to do. These two, actually, two parts are there. So two parts are there. Out of these two, first you have to name cationic part, then anionic part with gap in between, and the ligands are named according to alphabetical order. And if it is a cationic, ligands are same except what? Egg part, and one or more than ligands are same kind. So you have to use prefix di and what? Tetra. So these are the rules for what? Naming what? Coordination compound. Next. Yes, next. Yes, here. Now additional S. Next. Okay. Yes, my dear students. Here is the very important is. So what is the very important thing is S. So this is the K4 FeCl6. In K4 FeCl6, It is a complex. First is what? First you have to name what? Positive part. Which is the positive? Potassium is positive. First you have to write down positive part. Then you have to give a space. How many ligands are here? 6 ligands are. 6 ligand means hexane. What is the name of ligand? Cyanide. But you have to write it as a cyanido. Which is the central metal atom? Iron. Iron is the central metal atom. Fe. Fe is the central metal atom. But you don't write iron. You have to write it as what? Ferrate. Write it as what? Ferrate. Because so this is the central metal atom is iron. In case of what? In case of what? Anionic complex. In case of what? Anionic complex. In case of what? Anionic complex. So central metal atom. The central atom is ends with what? ATE. And one more example here. Yes, my dear student. So here I am making, this is the example. Which is the same positive part? Positive part is potassium. It is positive. So how many ligands are there? 3 ligands are. Try. What is the name of ligand? Oxalate. Oxalate means you have to replace E by what? Oh, it is called what? Oxalate. Which is the central metal atom? Aluminum. So it is not aluminum, it is aluminate. What is the oxidation state? What is the oxidation state? How many potassiums are there? 3 potassium. It is what? Plus 3. Okay. And next is what? Which is the X? Aluminum is what? X. We don't know. Plus of what? Plus of what? How many oxalate ligands are there? 3. What is the charge of oxalate ligand? -2. What is the charge of oxalate ligand? What is the charge of oxalate ligand? -2. Okay. So here I can calculate. Yes. One more example I am discussing. Yes. So how it is oxidized? Second example I am discussing. Yes. So here, for example, here I can take here. This is K4FeCN6. Which is the central metal atom? Sorry. Which is the counter ion? Potassium. Positive part is potassium. How many ligands are there? 4. Tetra. Name of the ligand is cyanido. So central metal atom is nickel, but you have to, the name is ends with what? 80. It is what? Nickel. What is the oxidation state? 0. Why it is 0? Because the potassium is, how many potassiums are there? 4. So what is the charge? 4 plus 4 into 1. It is 4. So how many cyanide ligands are there? How many cyanide ligands are there? Cyanide, what is the charge of cyanide? -1. And how many cyanide ligands are there? 4. And it is what? -4. Plus 4 minus 4, 0. So that's why the oxidation state of nickel is what? 0. Okay. So the next example is what here? Next one more example I can discuss. Yes. The next example I can discuss here. The next example is, okay, sorry. The next example is, okay, here one example. What is this example? I am taking this K3 here. K3 is what? Potassium. How many ligands are there? 6. So 3 ligands are there. Try. Oxalate. Chromium. The name is ends with what? 80. Chromium becomes what? Chromate. Oxidation state is 3. Why it is 3? So how many potassiums are there? Potassiums are +1 into 3. +1 into 3. So next is oxalate. Next is the oxalate. How many oxalates are there? 3 oxalates. What is the charge of oxalate? -2 is equals to what? Is equals to -6. But it is what? 3. -6 into 3. -6 3. But -3. But you have to write down only oxidation state is what? 3. So these are the examples. Next is what? This is for anionic complex. Next is the cationic complex. Yes, my dear student. In the cationic complex, just a minute. Yes. In the cationic complex, very important. Yes, first which is the cationic part? This is square bracket is cationic part. In this, so ammonia, initial letter is A. Aqua is what? A. Cl is what? C. Ammonia A, aqua A, C. Which comes first according to alphabetical order? First it is what? How many ligands are there? 4 ligands. Tetramine. Next, how many waters are there? Only one water. It is called aqua. Cl is called what? Chloride, but it is written as a chloride. Which is the central metal atom? Cobalt. You don't write cobalt. In case of cationic complex, name of the central metal atom is, in case of cationic, the central metal atom is only cobalt, not cobaltate. So what is the oxidation? Next is what? Which is the counter ion? Chloride. So it is called what? Chloride. What is the oxidation state? So how can you calculate this oxidation state is 3? How can you calculate this oxidation state is 3? So I can calculate how this oxidation state is. Cobalt we don't know. Cobalt we don't know. I can write what? X. So ammonia. How many ammonias are there? 4. Ammonia is a neutral ligand. 0. Next is what? Water. How many waters are there? Only one. It is also neutral. plus of Cl, what is the charge? It is what? Minus 1. Next plus of what? Plus. How many chloride ions outside the square bracket? 2. 2 into minus 1 is equals to 0. Finally we can get what? X is equal to 3. X is nothing but a cobalt oxidation state is what? 3. Okay? Yes, my dear student. Next slide. Okay. So these are the IUPAC names of coordination compound. Next is what here? Even the same it is also next is the valence bond theory. Yes, in the valence bond theory, the very important point you have to remember. So very important point, if it is a sp3 hybridization, it is a tetrahedral geometry. If it is a dsp2 hybridization, it is a square planar geometry. If it is a d2 or sp3 hybridization, it is a octahedral geometry. If the complex is n-1 dehybridization, so it is called inner orbital complex. If nd hybridization is involved, it is called outer orbital complex. And next is next one more point you have to remember. The next point is here. So the next point is here, n-1 is 1, and these are the valence bond theory. In this valence bond theory, the very important thing is if ligands are strong, ammonia is strong ligand, carbon monoxide is strong ligand, cyanide is strong ligand. So unpaired electron they are forced to pair up. So it is called what? Spin pairing. If these ligands are called what? Strong ligands, where the spin pairing takes place. Yes, my dear. The next is examples. Okay. Next one by one example is, so here the very important. So here this is CONS3 6 plus 3. Okay, which is the central metal atom? Cobalt. Cobalt is a central atom. Cobalt is a central atom. Cobalt is central atom. Okay, cobalt is central. And ammonia is a strong ligand. 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 So what is the electronic configuration of cobalt? 3d7 4s2. Yes, here 3d7 4s2, but cobalt oxidation state is what? Plus 3. So that's why the electronic configuration is only, the electronic configuration is 3d6. How many electrons are here? Total 6 electrons are here. But here what happens? So here ammonia is a strong ligand. So their unpaired electron in the 3d orbitals, they are forced to pair up. So it is called what? It is called what? Spin pairing. Because of this spin pairing, so what happens here? Because of this spin pairing, so this unpaired electron they are forced to pair up. So that's why, so the unpaired electron they are forced to pair up. The unpaired electron they are forced to pair up. So the next is what here? What happens here? Just a minute. Yes. Because of this, what happens here? Yes. So this empty D is filled with what? See here already it is because of what? Strong ligand. These are empty orbitals. These empty orbitals are occupied by what? Occupied by what? The electrons of what? Ammonia ligand. And here no unpaired electron. So no. This is octahedral geometry. When it is called octahedral geometry, so it is what type of hybridization? It is what type of hybridization? It is a D2sp3 hybridization. D2sp3 hybridization, it is a octahedral complex, and here no unpaired electron. It is a diamagnetic. It is nothing but it is a diamagnetic complex. And next is what here? Next here it is a diamagnetic complex, and next D2sp3, what type of geometry it is? It is a octahedral geometry. It is nothing but it means, so this is CONS3 6. So this is a CONS3 6 plus 3 complex. CONS3 plus 3 complex. So it is a what is the it is a diamagnetic complex, octahedral complex, and it is a D2sp3. And even though it is also called what? It is also called what? Inner complex. It is also called what? Inner complex. This is about what? CONS3 6 plus 3. Okay. The next slide. This go. The next is what here? The next slide is, next example is COF6. Just tell me, what is the COF6? In this COF6, what happens? This is the COF6, which is the central metal atom. Cobalt is a central atom. Cobalt is a central atom. So F is nothing but F is a weak ligand. F is a weak ligand. Okay, F is a weak ligand. If it is a weak ligand, it is nothing but a sp3d. If it is a weak ligand, it forms what? sp3d2 hybridization. If it is sp3d2 hybridization, it is an octahedral and it is a octahedral. Because of this weak ligand, the complex is what? Paramagnetic. The complex is what? Paramagnetic. The complex is what? Paramagnetic. This means this complex is a sp3d2 hybridization, octahedral geometry. Fluoride is a weak ligand and it is a paramagnetic, and even though if it is a paramagnetic, so what type of complex? It is a outer complex. It is nothing but a outer complex here. Okay, so this is it means this is weak. The previous one is strong ligand and this is what? Weak ligand. The previous one is diamagnetic. This is what? Paramagnetic. Previous one is inner complex and it is a outer complex. Yes, my dear. So next example. Next. Already we have discussed. Okay. Next, NiCl4, S minus 2. So this is I am discussing NiCl4. So this is in NiCl4, which is the central atom. Central atom is nickel. Central atom is what? Nickel. And Cl is a, and it is a, next it is what here? Next is Cl. Cl is a weak ligand. 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 So it is a weak ligand. Because of this weak ligand, what so in this next the electronic configuration is 3d8 4s2. The nickel oxidation state is +2 and it is 3d8. How many electrons are there? Total how many electrons are there? 8 electrons are there. Cl is a weak ligand. No pairing. No pairing means 2 unpaired electrons. 2 unpaired electron. 2 unpaired electron. 2 unpaired electrons. So hence it is a paramagnetic. Hence it is a paramagnetic. It is a why it is paramagnetic? It's a 2 unpaired electrons, so it is a paramagnetic. 2 unpaired electron. Cl is a weak ligand. Weak ligand means what? 2 unpaired electron. And next, what type of hybridization? It is a sp3 hybrid orbital. sp3 hybrid orbital is nothing but a tetrahedral. sp3 is nothing but a tetrahedral. So what the information here? So central atom is nickel. Cl is a weak ligand. Weak ligand means what? 2 unpaired electron. 2 unpaired electron means paramagnetic. And it is what type of hybridization is possible? sp3. If it is sp3, it is called what? Tetrahedral geometry. This is about what? NaCl4 2 minus. The next is what here? The next example is NaCl4. Yes, the next is what? NaCl4. In this NaCl4, which is the central metal atom? Central metal atom is what? Nickel. Central metal atom is what? Nickel. The Cn is nothing but a, Cn is a, which ligand? It is a strong ligand. If it is a strong ligand. It is a strong ligand. Strong ligand means what? Strong ligand means no unpair electron. No unpair electron means what? Diamagnetic. No unpair electron means what? It is a diamagnetic. Yes, here no unpaired electron. All are paired. And it is what type of hybridization? dsp2. If it is a dsp2 hybridization and it is nothing but a square planar. It is nothing but a square planar. It is nothing but a square. It means you have to remember strong ligand, no unpaired electron, diamagnetic, dsp2 hybridization, and it is a square planar. Okay. Next is all the 4 examples are over. And next is what here? Okay, over. Next, crystal field theory. So what is this crystal field theory? So in this crystal field theory, what happens here? In this crystal field theory, what happens? In an octahedral complex, the 6 ligands are on the central atom. There will be repulsion between the electrons in a metal, d orbitals, and the electrons of what? The ligand. So such repulsions are more when the metal d orbital directed towards the ligand when it is away from the. It means, so when the crystal field splitting is takes place, crystal field theory consider the metal ligand is what? Ionic. And there is electrostatic interaction between metal ion and the ligand. There is a electrostatic interaction between the metal ion and the ligand, and this is the crystal field theory. And if ligands are neutral, the interaction with metal ions are ion dipole interaction. In the crystal field theory, when the ligand approaches towards central atom, so if the ligand approaches central metal atom, so d orbital. So in the crystal field theory, what happens? The d orbital split into what? Split into 2 sets. split into two sets. Splits into what? Two sets. So it is called what? Crystal field theory. Next. See here. So here what happens here? So in the actually the d orbital. The d it contains how many orbitals? Dx square minus y square. These orbital which point towards the axis along the direction, the ligand will experiences what? More repulsion and raised energy. Okay, easy. These are dx square minus y square and d square. It is called what? Easy orbital. It is called easy orbital. The ligands of the electron metal repulsion in the octahedral complex will three orbitals of lower energy. These lower energy orbitals are called what? T2z. So this is dxy, dxy, dyz and dzx is called d2z, and dx square minus y square is called ez. The splitting of these two t2z and ez is called what? Ez is called what? Crystal field theory. So which has the higher energy? Ez is what? High energy, and t2z is what? Lower energy. It is nothing but it is a lower energy orbitals. These are the lower energy orbital, and Ez is nothing but a higher energy orbital. It is nothing but a higher energy orbital. Higher energy orbital. So, okay, now I can show with help of this diagram. All of this here. Yes, this is the diagram. Is very important. Yes. What is this diagram? I can explain here. So this is what I put. This d orbital. Yes, d orbital. D orbital splits into d orbital splits. So d orbital splits. What is splits into what? Dx square minus y square and dz square. It is called Ez. Ez means what? High energy. Ez means what? High energy. Ez means high energy. High energy. And it is called dx square minus y square. It is called what? This is called this. It is called what? T2z. This is T2z, and it is called lower energy. It is called lower energy. It is called lower energy. The splitting of what? The splitting of d orbital into Ez set. Splitting into Ez set and what? T2z set. So it is called crystal field splitting. The energy between Ez and what? T2z. The energy between Ez and T2z. It is called what? It is called what? CFC. CFC means what? Crystal field splitting energy. It is called crystal field splitting energy. The splitting of the degenerate level due to the presence of ligand of the different geometry is termed as a crystal field splitting. This d orbital, 5d orbitals, these 5d orbitals. Okay. So here all these 5d orbitals. Okay, my dear students. Yes. So here this 5d orbital, these 5d orbitals split into what? Two set. One is Ez set. This is called Ez set, and these three are called what? These three are called what? T2z set. It is called what? Crystal field splitting. The energy separation between this Ez and what? The energy between Ez and T2z. The energy between this Ez and T2z is denoted by what? Delta. Okay. Yes. The next slide. Okay. Just a minute. Yes. Previous one. Yes. This is a very important. Yes, my dear students, I can discuss here. So the energy difference between two sets, Ez and T2z. This is called what? Crystal field splitting energy, and it is denoted by what? Delta Ez. The energy difference between Ez and what? T2z. Okay. The energy difference between Ez and T2z level is called what? Crystal field splitting energy. And the next is what are the strong and weak ligand? The crystal field splitting is what? Large, and it is called what? Strong ligand. And small crystal field splitting is called what? Weak ligand. If the splitting is large, splitting is what? Large. It is a strong. It is a strong ligand. If splitting is what? Splitting is a small crystal field splitting. It is called what? It is called what? Weak. It is called what? Weak ligand. Okay. So what is the strong ligand? Splitting is large. What is the weak ligand? Small crystal field splitting is weak ligand. The large crystal field splitting is called strong ligand. Yes, my dear. Next. Yes, spectrochemical series. This is a very important thing. What is the spectrochemical series? In spectrochemical series, ligands are arranged in the series order of increasing. So this is a weak ligand, iodine is weak ligand. Which is the strongest one? Strongest one is the carbon monoxide. Carbon monoxide is a strong ligand. Is a strong ligand. Is a strong ligand. Why it is called strong ligand? Why it is called strong ligand? Splitting is what? Large. Splitting is what? What is this symbol? Splitting is what? Large. Splitting is what? Large. The splitting is large, so it is called what? Strong ligand. Splitting is what? Small, it is called what? Weak ligand. So depending upon the splitting, so the ligands are arranged, so it is called spectrochemical series. Next. Next is here. Okay. Next there is one. Yes. Okay. Yes. Next is what here? The next is the crystal field splitting depends on. Yes. The very important thing is the crystal field splitting. Yes. The crystal field splitting, it depends on nature of ligand, oxidation state of the metal, and nature. The same crystal field splitting in what? Tetrahedral geometry reverse. In the previous one is what? First is what? Easy, and next is what? T2Z in octahedral. But in case of tetrahedral, so what happened? The first is what? T2Z, and the next is what? Easy. So here in octahedral first is what? Easy and what? T2Z. Here first is what? T2Z, and next is what? Easy. Next, it is the reverse of what? Octahedral. Yes, coordination, coloring coordination compound. Yes, coloring coordination compound. Yes, here what happened? Coloring the coordination compound, which actually, for example, the TiH2O6 plus 3 is a violet color, because the violet color what is what is the oxidation state of titanium? Titanium is what? Plus 3 means what is the electronic configuration? 3D1. So here what happens? If the light corresponding to the energy of yellow green region is absorbed by the complex, the electron from T2Z level to EZ level. It means the electron present in T2Z gets excited to what? EZ. Okay, here I can show this. Okay, see here. The next is what here? Okay. In case of titanium, in case of titanium, the one electron is in the ground state. When the light falls on this, what happens? This electron present in the ground state is excited to what? EZ level. So by this excitation, so it shows what? Color property. Because of excitation of electron, it shows what? Color. Okay. Next is what here? Isomerism coordination term. Yes. What is isomerism? See here. So it is a very important. So the next is what? Suppose for example, if same ligands is present on 1 and 6 position, and if the same ligands are present on 2 and 4 position, and the third and 4th position, if two same ligands are in the opposite position, 1 and 6th position, and 2 and 4th position, and 3 and 4th position, so this type of is called what? This is called what? Trans. It is called what? Trans. If ligands are if one ligand is in first position, one ligand in 6th position, it is called what? Trans. If two same ligands are in the corner side, it is also called cis. If two same ligands, one is present on 3rd position, one is present on 3rd position and 5th position, so these are called what? Trans isomerism. So when it is called what? Cis isomerism. If one ligand is present on 1 and what? One ligand is 1 and 2 position. It shows what? Cis isomerism. For example, one ligand, so same ligand, one is on 1st position, one is on 3rd position. It is also called as cis isomerism. For example, one ligand is in 1st position and one ligand is in what? The 4th position. If the same ligand is in 1 and 4th position, it is called what? Cis. And similarly what happens here? Next, for example, one ligand is on 1st position and the same ligand is in the 5th position. It is also called what? Cis isomerism. So this is about what? Isomerism. Okay. Next is what? Geometrical isomerism in square planar complex. Okay, geometrical isomerism square triangle. Yes. So here very important is, my dear students. So this is called what PT. Here the two same ligands on the same side. It is called what cis. Here the two same ligands is on the opposite side. It is called what trans isomerism. So it is called what Ma2B2 type. It is also called M2X2L2. It means total 4 ligands are there. So 2 are same, another 2 are what same. It is called what geometrical isomerism, that is MX2L2 type. Next is what? Next example, geometrical isomerism. Next example. Yes, my dear student. Yes. Okay. Just here. Okay. Come. Next. Okay. See here. Okay. Just here. Okay. Next is what here? Yes, my dear students. The very important thing is here what happens already we have discussed. It is how many are there? 6 ligands are there. Out of 6 ligands, 4 are safe. Remaining 2 are safe. 4 safe plus 2. Total how many? 6 are there. Here already we have discussed. First position and second position both are same. Previous already we have discussed. First and second position the ligands are same. It is called what cis. Here this is called what first position and this is called what fourth position. The same ligands are in first and fourth position. It is called what? It is called what? A trans isomerism. It is called what? Trans. 1 and 2 positions are two ligands of 1 and 2 position is cis. The same ligands of 1 and 4 position is what? Trans. It is what? 4 plus 2. Why it is called 4? 4 ligands are same. 1, 2, 3, 4 ligands are same. Another 2 ligands are different. Yes, my dear student. Next example. Yes, my dear students. Yes, here. Here also same, my dear students. Here also same. How it is same? It is what type of ligand? MX2. MX2 means these are the X. LL2 means what? LL2 means nothing but a EN2. It is called bidentate ligand. LL means bidentate. MX2 it is a monodentate. Here 1 and 2 position it is called what? Cis. Here 1 and 4 position. 1 and what? 4th position it is called what? Trans. So it is means what? 2 are bidentate. Remaining 2 are first 2 MX2 means these 2 are monodentate and LL means what? EN. EN is nothing but a EN is the bidentate. But in what is the cis isomerism? 1 and 2 positions are called cis. And the same ligand is in 1 and 4th position. It is called what? Trans. It is of what? MX2 type. Next is here. Next example. M3B3 type. Okay, so it is called M3B3 type. What is this M3B3 type? See, M3B3. A3 means A1, A2, A3. So this type of isomerism is called facial isomerism. And next, this is what? B3. This is what? B3. This is what? B3. So this is A. This is A type. A3. Next it is what? B. It is what? B. And sorry, it is what? B. So this type of arrangement is called what? Is called what? Facial arrangement. It is called what? Facial isomerism. Next is what here, my dear students? Next is here. Okay. The next is okay. Here is what? Is this what? This is what? A. Next it is what? A. Next it is what? A. Okay. Next is what here? This is what? B. This is what? B. And this is what? B. Okay. A3, B3. Okay. So this type of A arrangement it is called facial arrangement. And next is what? One is A. One is A. And next is what? Next immediately is what? This is what? A arrangement is facial. It is called facial. Next, what is the arrangement here? Arrangement is what? A, B, otherwise B, A. This type of arrangement is called what? Is called what? Meridian. It is called what? Meridian. How to, so A, complete A arrangement is facial. Or complete B arrangement is called facial. A, B or B, A arrangement is called what? Is called what? The facial and what? Meridian arrangement. Next is what? The next is what? Yes, actually this type of geometrical isomerism is not possible in what? Geometrical isomerism is not possible in MX5 and what? MS6. If all ligands are same, for example CO, NH3, NH3, 6. It not shows what? Geometrical isomerism. It not shows what? Geometrical, because all ligands are same. Not shows isomerism. Even though CO and it is what? NH3 and this is what? 5 and it is what? Cl. This also not shows what? These two are not shows what? Geometrical isomerism, because MX6 means CONS6. All the 6 ligands are same. Here 5 ligands are same, one ligand is different. Even though this also not shows what? Geometrical isomerism. And next is what here? And the next thing is what here? What is this optical isomerism? Which have same molecular formula and the physical properties are different rotation is called. If optical isomerism cannot superimpose on the one another, these are called what? Chiral. What is the dextrorotatory? The rotation of plane polar right towards light is called towards the right is called what? Is called dextrorotatory. And next towards the light is towards the left is called what? Left is called levorotatory. Yes. Okay. Examples here. So this is what anybody. Yes. Here. This is the dextrorotatory. They are the mirror images of each other. These are the mirror images of what? Each other. So this is called what? This is called what? The optical isomers. Okay. Next example is. Okay, my dear students. The next example is same. Next example same. They are the mirror images of each other. Yes. These are the yes. Here is En. Here is En. Here is En. Here. So this is here. They are the mirror images of each other. They are mirror images. They are the mirror images. If they are mirror images, it shows what? It shows what? Optical isomerism. It shows what? Optical isomerism. If they are mirror images are there, so it shows what? Optical isomerism. Okay, my dear students. Next. Now the structural isomerism one by one. Okay. In the structural isomerism, my dear students. Okay. So here the formula is same. CO, NH3, NO2, NO2. So formula is same. So formula is CO. Both have what? Same formula, but only differ is what? Here oxygen is the donor. Here oxygen is the donor, and here nitrogen is the donor. So that's why it is called what? Linkage isomerism. So formula is same. CO. Here is NH3, here is NH3, here is NO2, here is NO2, here is Cl2. So formula is same, but only is the differ in what? Here is the oxygen donor, and here nitrogen. The coordination compound containing ambient and coordination compound have same molecular formula. Formula is both have same formula, but only is the differ in what? Attachment of what? The mode of attachment. Here the mode of attachment is oxygen. Here mode of attachment is nitrogen. Formula is same, but here the donor atom is oxygen. Here donor atom is what? Nitrogen. So it is called what? Linkage isomerism. And next is what? Coordination isomerism. What is this coordination isomerism? Yes, my dear students, this is the coordination isomerism. In this coordination isomerism is what here? This coordination isomerism, what happens here? This is here is CO, here is CO, here is Cr, here is Cr, here is NH36, here is CN6. So formula is same, but only is what? Exchange of what? There is only interchange of what? Ligands. Only interchange of what? Ligands. So that's why it is called what? Interchange of ligand means here is the CONS36, but here CrNH36. Here CrCN6, here COCN6. Only is the exchange of what? Ligand. So that's why it is called what? Coordination isomerism. Next is ionization isomerism. Next is what is the ionization isomerism? Okay, my dear students. What is this ionization isomerism? Okay, what is this ionization isomerism? So here what happens? Okay, my dear students, I can discuss here. Yes. The formula is here. Here is CO. Here is CO, here is CO, here is NH35, here is also NH35, here is SO4, here is SO4, Br. So formula is what? Same, but here the counter ion is same. The first example, the counter ion is Br minus, and in the second example, the counter ion is what? SO4 minus 2. Formula is same, but here, which is the counter ion here? Here Br is the counter ion. So here SO4 is the counter ion. The formulas are same, but the counter ions are what? Different. So that's why it is called what? Ionization isomerism. Okay, my dear sir. Here CO. Next it is what? NH3. I am writing this is NH35. NH35. This is what Br, and next it is what SO4. This is what SO4. Okay, my dear students. Yes. One more example is here. Yes, here. Okay. Now I am writing here. One more example is what CO, and this is what NH35. This is NH35, and here it is what SO4, and it is the SO4, and here is what Br. So what is the difference? CO, CO. NH35, NH35, Br, Br, SO4, SO4. Formula is same, but here counter ion is SO4 and here counter ion is Br. This type of isomerism is called ionization isomerism. The next is what solvent isomerism or hydrate isomerism. What is the solvent or hydrate isomerism? Okay, what is the solvent or hydrate isomerism? Here is chromium, here is chromium, here is 6 water, here is 5 plus 1, 6 water. Here Cl3 and it is also Cl3. Formulas are same. Formula is what? Same. Formula is what? Same. Okay, formula is what? Same. But only different is what? One is hydrate isomerism in case water involved as a solvent. In this compound what happens? Molecular formula having same molecular formula but differ when solvent molecule is directly bonded to metal atom or present as a free solvent. Here is what? Here 6 water molecule, here 5 is inside the square bracket, 1 is outside, so only the differ is what? Water molecule, so it is called what? Solvent isomerism. Next is what? Next is bonding in metal carbonates. So what is bonding in metal carbonates? What is the bonding in metal carbonates? So this is called the bonding in metal carbonates. So the carbon monoxide is directly linked to what? Directly linked to what? Metal, so it is called what? Metal carbonates. So this is NiCO4, Ni is the central metal atom, so 4, this is the tetrahedral geometry, this is FeCO5, it is a trigonal bipyramidal, and it is a Cr, this is nothing but a CrCO6. So these are the examples of what? These are the examples of what? Metal carbonates. The next is what here? These are next bonding. Synergic bonding interaction in carbonyl compounds. What is the synergic bonding in what is the synergic bonding in this compound? And this is in the metal carbon bond in the metal composites what over both sigma bond and what? Pi bond. And the metal and carbon is a sigma bond is formed by the duration of what? Lone pair. Actually the metal and what? Carbon bond is formed by what? Formed by what? Sigma bond. And the next metal carbon pi bond. This is what it is. This is nothing but a metal and carbon pi bond. This is the pi bond is formed by the donation of pair of electron for filled d orbital of what? Filled d orbital of what? This is the metal. So this is nothing but a, so it contains metal carbon bond and metal carbon sigma bond, and metal. So this pi star orbital of carbon monoxide, the metal again bonding creates a synergic bond which strengthens the bond. Bond. Okay. So this is about metal carbon. Next is what? Next, importance of coordination compound. This is a very important concept. Okay. So this the hardness of water is estimated by simple titration with water EDTA, and with help of this EDTA, so we can determine what? Calcium and magnesium ion. Okay. So this is hard, and this is the coordination compounds are of great importance in biological system. Mainly the pigment responsible for photosynthesis, that is nothing but a chlorophyll. Chlorophyll is a magnesium complex. Next is the hemoglobin, is a red pigment of what? Blood, and which acts as an oxygen carrier, coordination compound of what? Iron. Hemoglobin is a coordination compound of iron, and chlorophyll is a coordination compound of what? Magnesium. And vitamin B12 is called cyanocobalamin, and it is a anti-furnaces anemia factor, and is the coordination compound of what? Cobalt. It is a coordination compound of what? Cobalt. Yes, my dear student. Next. Last is the coordination compounds are used as a what? The coordination compounds are used as a catalyst for very industrial example, rhodium complex. The rhodium complex, it is also called what? Wilkinson catalyst, and it is used for what? Hydrogenation of what? Alkene. It means alkene plus hydrogen. So alkene plus hydrogen. So alkene plus what? Hydrogen, it gives what? Alkane. Alkene plus hydrogen, it gives what? Alkane. But here we can use use what? We can use what? Wilkinson catalyst, or it is also called what? Rhodium complex, which is the central metal atom. It is a rhodium is the central metal atom, and triphenyl phosphine, it is a PH3P, PH3P, it is called triphenyl phosphine. It is called triphenyl phosphine as a ligand. Triphenyl phosphine as a ligand. Okay, so these are the some points regarding what coordination compound. Thank you, and have